Hello, I'm Sam from Niche Solutions, and today we'll be taking a closer look at biofilm identification and elimination in the brewery. Biofilms can be allowed to develop when brew kits are unused for some time and are often the cause of beer spoilage. Let me pass you over to Paul Browning, who's a microbiologist and CIP expert, and he's going to talk you through how to eliminate biofilms, but even better, how to prevent them in the first place.
Hello, I'm Paul Browning, and I'd like to welcome you to this Niche Solutions information video. And it's to do with the fact that we're now discovering, and this probably goes back over the last 10 or 20 years, that the preferred lifestyle of bacteria in food, beverage and beer manufacturing is in a biofilm. In other words, bacteria love to stick to surfaces. I've been involved in investigating microbial contamination in breweries now for several years. Now, more than 90% of bacteria floating around in a brewery, whether it's in the wort or the beer or the water or in the environment, over 90% of those microorganisms are going to be living in a mixed community in what we call a biofilm. Now, we're all familiar with biofilms. Perhaps we think of a stream bed, or if you've ever been at the seaside walking over rocks and they're very, very slippery, that's biofilm. Biofilm is also called plaque, which we find on our teeth. So we've been in touch with biofilms in nature for many, many hundreds of years, but in recent times, most of the infections within breweries will be bacteria contained within a biofilm. And there's one big problem with that, and that is conventional chemistry will not remove well-developed biofilms. This product called BioFinder is a tool that I would recommend that every brewery considers using as part of their hygiene program. Biofilms contain, without question, all biofilms will contain the enzyme catalase. And when catalase comes into contact with hydrogen peroxide, it produces masses of microbubbles of oxygen. And what happens is that the translucent orange colour sitting on top of the biofilm turns a creamy white colour. And if we look closely enough, we'll see millions of microbubbles of oxygen. That's telling us we have a biofilm problem. So what we're going to do right now is go into a brewery and show you how this works. So let's start off on the hot side of the brewery. Now, in real terms, biofilms are less likely to be found on the hot side of the brewery because, of course, the mashing process, the boiling process is using very high temperatures. So whilst I would encourage you to focus on the cold side of the brewery, which we'll look at in turn, we also want to include the hot side. So here we are at the mash tun. BioFinder has been sprayed, first of all, onto the floor where we've got a very strong positive reaction. Now, if you find biofilm on the floor of your brewery, that is quite normal. Biofilms love, they love just wet environments. Floors offer a great source of nutrients in the way of wort or beer or both. And many floors, through being used for many, many years, are very often open and porous and damaged. Seals may be broken where drains butt onto the floor, and these are all likely hiding places for biofilms. Biofilms will be found on the brewery floor. And the important thing to remember about that is that when we look at where the mash tun outlet valve is, it's just a few centimetres from the floor. Now, on this particular occasion, BioFinder was applied to the outlet valve. It was applied to the manway door and the door rubber, and to the plates which were sitting inside. Now, all of these surfaces had previously been chemically cleaned by conventional chemical methods. And we found no biofilm whatsoever in or on the mash tun, but we found profuse amounts of biofilm on the floor, which means that that biofilm could be transferred. We call this cross-contamination. It could be transferred simply by people walking on the biofilm. Fragments, very tiny fragments, get separated from the bulk of the biofilm, These can float up and infect open valves such as this on the mash tun. Right, let's move over now to the cold side of the brewery, and we're going to start with the fermenting vessels. And the chances are that if you have an infection which is causing souring or wild yeast problems or taint problems, that many of the beer spoilage organisms, particularly wild yeasts, will form, not all of them, but many of them will form biofilms. So moving over to the fermenter, here we see again the proximity of the outlet valve to the floor. And whilst we've tested the outlet valve, and this showed no signs of a biofilm being present, and just to remind you, the nice, clear, orange viscous liquid called BIOFINDER didn't change colour and didn't produce microbubbles of oxygen, indicating we have a microbiologically clean surface. But just look at the profuse biofilm just centimetres immediately below the outlet valve on the FV. Moving up the FV, we've dismantled the sample cock. And if we look at the inside fittings of the sample cock, we can see we have a couple of O-rings. These are the kind of places that biofilms love to grow in. Anywhere we have small gaps or niches, anywhere where the CIP is not covering. So I would urge you to clean sample cocks separately. But here, 10 out of 10 to this brewer, because this fermenter is very, very clean, both on the outlet valve and here on the sample cock. Moving up to the top, where we have the manway door and the manway door rubber, these are hot spots for biofilms for the simple reason that CIP doesn't always reach all aspects of the manway door. There is very often a lip inside which can produce a blind spot. A blind spot means that some of the spray from the rinse, from the detergent, from the peracetic acid may not be covering the entire circumference of the manway door or the door rubber. The other things to check are stainless steel pipework and beer transfer hoses. So from time to time it's a good idea to test these, but certainly the transfer mains or the transfer hose here, which is made of rubber of course, biofilms will grow on highly polished stainless steel, but the rougher the surface, the more chances are the biofilm will grow. And on this occasion, again 10 out of 10 for the hygiene program in this particular brewery, the test was negative, indicating a microbiologically clean transfer hose. Something that's very often overlooked in many food, beverage and beer factories are the cleaning tools. So be careful that you test, in this case, a squeegee, a nylon brush, and these were very well branded products, and also a scouring pad. All of these are used to clean things in the brewery, and in this particular case all were very heavily infected with biofilm. So by brushing and squeegeeing and using the green pad, we're causing cross-contamination. We're using these to clean, whether it's floors or walls or the outside of the vessels, or even components such as valves with the scouring pad. And what we're doing is exactly what we don't want to do. We're introducing more microorganisms, because within any biofilm, we're going to have millions upon millions of a mixed species, three-dimensional consortium of microorganisms, and some of those could spoil your beer. So here we are in the cellar, and this is typically a cellar. It's below street level. We see that we have biofilm on this cross member, and we've actually got a positive response on the end of the spray device, which rinses and cleans and disinfects the cask. And what has happened here is that a biofilm has started to grow inside the slots at the top of the spray device where the detergent comes out and circulates into the cask. So a word of warning with cask racking: make sure that the dilute detergent tank, the rinse tank, the disinfectant tank are thoroughly cleaned out at least on a weekly basis. and make sure that spray devices are removed and checked. It's not been uncommon in summertime to see flies and maggots being trapped inside the spray device because they can't get out, and this is where we get the biofilm starting to grow, when organic matter from the cask gets lodged inside the spray ball. So what are we going to do if conventional chemistry won't work? What else can we use? We can look at enzyme surfactant technology. Enzymes are catalysts, and they work in a completely different way to caustic detergents and caustic hypo blends. What they do is solubilize, or if you like, they break the biofilm down into water-soluble molecules, which can be then easily rinsed away. Now, once we've done that, we've removed the shelter, we've removed the protection the microorganisms had, but now they've been released. We need then to apply a strong terminal disinfectant. Peracetic acid is the preferred approach. It's about 250 ppms, and we apply that immediately after the foam cleaning cycle, which lasts about 15 to 30 minutes. Follow it with a rinse, hit it with peracetic acid, infection over.
Thank you very much, Paul. That really highlighted the importance of using enzyme cleaners alongside conventional chemistry to prevent biofilms from developing in the first place. Please check out our other video to see the enzyme cleaner available from Niche Solutions.